Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 238, which is called product of array except self. And this is one of the ones that I would say it's kind of tricky, and once you start getting to this difficulty, these are the types of problems that you can definitely be asked during a CumSci interview. So let's get to read the problem statement. Given an integer array nums, return an array answer such that answer sub I is equal to the product of all the elements of nums except nums sub I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. Okay, so as we can see, example 1, we have the following input, 1, 2, 3, 4. And the output is this because for the first element, so we would have 2 times 3 is 6, times 4 is 24. For this one right here, we multiply every number except 2, so it's 1 times 3 times 4, which is 12. For this one, the same thing, all of them except 3, so it's 1 times 2 times 4, which is 8. And then for the last one, we repeat the same thing, 3 times 2 times 1, which is 6. Similarly here, all of them are 0 because there's a 0 except the one that corresponds to the 0. So that would be 1 times negative 1, which is negative 1, times negative 3 times 3, which is negative 1, times negative 9, which is equal to 9. Okay, so if you want to give this problem a try by yourself, now would be the right time to stop the video because I'm going to explain how to solve this problem. All right, so let's get to it. So suppose we have example 1, right? So we start with a 1, 2, a 3, and a 4. And our idea is that in the output, for any position I, the value for I is the product of all the numbers except that one. Now, what I mean by this is like, suppose, well, we have these indices right here, 1, 2, 3, and 4. So for, let's say, 1, right? Or let's pick this position. I think it might be easier to see what I'm talking about. So for position with index 1, we want the product of this and the product of this. Now, saying that the product of all numbers except itself, that is equivalent to saying we want the product of all the numbers to the left of the current number multiplied by the product of all the numbers to the right of that number. Right? It is true to say that the product of 1, 3, and 4, so the product of all the numbers that are in 2, is the same as the product of all the numbers to the left of 2 and all the numbers to the right of 2, because those are the only two positions in which we can find a 2. So if we think of the problem this way, then we can maybe make it a little bit easier. The idea here is to first compute all the left products, if you want to call it that way. So for example, as we traverse through the array 1, 2, 3, 4, we want to find what the product of all the numbers to the left of the current number is. Obviously the first element, right? There are no numbers that are on the left of it. So we can just simply set the default number of those products equal to 1. Because we're later going to multiply the left times the right. And if we set it up equal to 0, then it would always be 0, and we don't want that. So if we initialize, right, this number as a 1, and we want to find the product of all the numbers to the left of this number, then all that we need to do is simply multiply this. So this right here, let's write it down. This represents the products of the numbers to the left of that number. So in the beginning, it's a 1, which means that all the numbers to the left of 1, in this case there are none, end up getting a product of 1. So then it follows, right, that in here, for 2, this number will be equivalent to the product of all the numbers to the left of 1 times 1. So 1 times 1 will be 1. For 3, because, right, we're only adding one number at a time. All the numbers that are to the left of 2, right, are the same as the numbers that are to the left of 3, except that on the left of 3 we also have 2. So all that we simply need to do as we loop through a loop to calculate this is to use the previous product of the number to the left of it and multiply by that number itself. So in this case, now 2 multiplied by all the product of the numbers to the left of 2, which is 2. And similarly here, it will be 2, so the product of all the numbers to the left of 3, multiplied by 3, which is 6. 3 times 2 is 6. And this is the product of the numbers to the left of each number. We can check this by hand. So for 1, we just set the default as 1. And then for this one, it's 1, right? So there's a 1 here. To the left of 3, we have 1 and 2, which is equal to 2. And to the left of 4, we have 1 times 2 times 3, which is equal to 6. Now we can do the same thing with the products of the numbers to the right of that number. And in this case, we would start on the right part of the array instead of the left one. So products to the right of that number. And here we're going to start at the end. So this is going to get a little bit messy with the spaces, but essentially we started with the default as 1. And here we do a similar thing. We look at 1, 2, 3, and 4, right? What are the numbers to the right of 3? 4. The product of the numbers to the right of 4 is 1. Therefore, the product of the numbers to the right of 3 will be equal to whatever we found before multiplied by 4, which is a new number that we add there. So we simply do that. And now we go back to the 2. For the 2, just like what we did in the other one, it will be the previous number that we encountered, which is the 3, plus the cumulative sum, which is 4. So there's a 12 there. Sorry. And then at the end, I keep hitting the what is it called? The light button. And for the right one, it will be the rolling product from before multiplied by the number that we have to add, which is 2. So here is a 24. And then at the end, all that we have to do is just multiply each corresponding place with the left and right. So then the end would look like a 24. So 24 times 1. And then the next entry will be 12 times 1, which is 12. 4 times 2, which is 8. And 6 times 1, which is 6. And this ends up being the result that we're doing in the output. So let's get to programming now. I'm going to comment all this so that we can use it as reference. And let's start. So first things first, we want to return some sort of array. So we will have this, and we will use a left array to represent the numbers to the left of that number, and a right array to represent the numbers to the right of that. So, there you go. Left. And we will initialize all of these to 1, just because you'll see in a bit. The main thing is that for the left one, it doesn't really matter, but for the right one, I do not want to be appending because we're going to be filling the numbers from the right to the left. And I don't want to insert it in the beginning of the array. So I'm just going to do the following. And since we're going to do several loops, I'm also going to define the length of nums as a variable, just so that we don't keep accessing like the same thing all the time. But we have this, so this will be that, and that'll be that. Those are the default values for the left and the right array. Okay. Now let's calculate the numbers to the left. So as we all know, right, we said that the number to the left, so the leftmost number does not have any numbers to the left of it. So that one's not necessary to calculate. So we can start calculating at the second one. So for I in range 1 through n, we now perform the operation. So what is the current entry in left equal to? Left sub I will be equal to, and remember that here, right, we are starting at 1 and we want to calculate the previous entry, so it'll be I minus 1, right? We're using the previous entry on the left array. And we multiply that by the current number that we encountered before. So in this case, it would be the 1. So it will be nums sub I minus 1. And that calculates the left array. Now let's do the right array. So the right array, we're going to go from right to left. So here, I believe this is the method. Yes, it is. Okay. It's an actual keyword, so I'm guessing it is. But the main idea here is to also start at the right of the array. So here, we start with all the way to the right. So for I in reverse range n minus 1, now we start at the right. So right sub I is equal to, and let's see. So the reason why, another reason why we're doing not range n, remember that this is exclusive. So if we have, let's say, length 4, right? Range n goes from 0 to 3, and the 4 never counts. But if we want to access like the previous number, right? Just like we did here, we started at 1 for the left. We have to do range n minus 1, so that n minus 1 ends in here, so that we can actually access this and not like and we don't get an out of bounds exception on the array. So right sub I here will be equal to the previous right product, which is represented by the entry that is on the right of the current one. So in this case, instead of I minus 1, it will be I plus 1 times the number that we previously encountered. And remember that we're going from right to left. So similarly, instead of being I minus 1 this time, it's I plus 1. And then at the end, all that we need to do now is just loop through the left and the right arrays and just multiply like left sub I times right sub I, and then append it to the array that we want to return. So for I in range n, to return dot append left sub I times right sub I. And then we simply return to return. And this solution should work. Now, as you can see, runtimes can be a bit inconsistent, but I have to say that this is not the most optimal solution. Runtime wise, it is. At some point, it beats like 70-80% of solutions because I tested it before. There you go. But there's also a small improvement that we can make to this, right? So right now, we're looping through the arrays in a good manner. I would say it's pretty efficient runtime wise, but we are using a left left array and a right array, which take extra space. The space-time complexity of this solution, in fact, is big O of n, because both the left and the right array store n terms in them. And besides the obviously like the output, which we don't really usually count towards the space-time complexity of a solution. But I can show you how we can actually avoid having to use these problems by simply tweaking this algorithm a little bit. So the idea behind this, right? The idea behind tweaking it is to not use a left and a right array, but still do the same operations in a more abstract way, but giving you the same result. So the idea is that we can use, for example, the array that we want to return as the left array. And remember, we don't count this towards the solution because no matter what, we're always gonna return it, right? So the idea is to avoid using extra unneeded space, and we always need the to return array. because that's the actual result that we want. So instead of using this, right, as the left, what we can do is we can just use the toReturn as the left array. And how are we going to do that? Well, just like we did with the left, right? What we can do is we can just initialize the toReturn, like the left. And here we're not really going to do like many changes to the algorithm. Instead of saying left, right? All that we're going to do is replace the toReturn with the left. And we agree that at this point, right, the toReturn is equal to the left array, right? There really isn't like any difference to what we've done so far. We simply changed the name of this variable and this from left to return. Now, how do we get rid of the right array? Because at this point, right, we can't really manipulate the toReturn array like we've been doing with another thing, right? So the main idea here is to use something that we can call like a cumulative product, if you want to call it that way. At any point, right, in the multiplication, we're always keeping track only, like whenever we calculate, a product, we're only keeping track of what the previous product is of the right element. So for example, when we are in here, products to the right. So when we are in here to calculate this, we only focus on one number on nums and one entry on the right. So what we can do is, instead of having an array and just focusing on the previous entry, right, we can create a variable, just one variable that keeps track of what the previous product was. And that way we can just simply get rid of this. And how do we do that? Well, the main idea here, right, is that first we can create something like right product. Let's call it like this. And we initialize it to 1, because remember, this will be the same as setting like the default value in the right array equal to 1. And after that, all that we need to do is the following. So we start at here. Let's see. This is the left loop, right? Sorry for that. So I'm gonna separate this so that it's like a bit more clear. So here now we're gonna be reversing the range, okay? And what we're gonna be doing is, okay, so we start at some point, right? And the idea is that the toReturn array has the products of the left, right? So what we are going to do now is, okay, we are going to calculate what answer sub I is using previous information that we've used so far. So for example, toReturn sub I at any point is equal to whatever the right product, which is the variable right product, times itself. Because we've already calculated the left values, right? So at this point, we're just simply multiplying the right values, right? This is simply just multiplying the previous, like whatever we have stored before from the left. And then all that we're doing is just multiplying that entry by the right product, which in this case will be equivalent to right sub I in this loop. Right sub I here corresponds to right product. And once we've done that, all that we need to do is find what right product will be now. And what is right product now? Well, right product gets updated by the entry in nums. Remember that here, right, if we start at 1, this is the right array. So if we start at 1, what we can do is multiply 1 by 6, right? And after that, if we start with, let's see, I think it might be easier to see this, but if right product is 1, here we start setting up the left. So this will be the toReturn array before we've entered this loop. Right product is equal to 1. What we can say is toReturn sub I is equal to right product times toReturn sub I, which is a 6. And after that, we update the right product with this entry right here. So nums sub I, right? So right product now is equal to right product times num sub I. And remember that this just keeps rolling. So now right product will be equal to 1 times 4. And I'm going to keep writing it this way so that you see the whole idea behind this, because this is the same as what we were doing before using the previous entry. At this point now, we use, on the next iteration, to return sub I is equal to return sub I times the right product, so 2 times 4. So we update this with 8. And now what do? We update right product with this times the 3. So now it's 12. What is the next entry here? 1 times the right product, so 1 times 12, which is equal to 12. And what do we do with the right product? We update it by multiplying it with the current entry in nums that we're looking at, 2. Now, what is right product here? 1. We multiply, to return sub I, it's 1. And we multiply to return sub I by right product, so 4 times 3 times 2, which is 12 times 2, which is equal to 24. And then we simply, all that we need to do now is just return to return. And that'll be the end of the algorithm. And that's how you simplify the solution from the previous one to this one. And obviously, like, runtimes here right now are, a bit inconsistent. But yeah, there you go. Now it beats 99% of the solutions and it uses less space. So this is how you would optimize, right? In a regular interview, an interviewer will probably be satisfied if you come up with the first solution and then you end up optimizing that solution for that for using less space than what you did before. Because right now, the space-time complexity of this problem is big O of 1. Because, obviously, right? Oh, by the way, there you go. I think this will be better. Now it's actually big O of 1. So that should be a bit better, space-time complexity-wise. But yeah, now the space complexity of this problem is big O of 1 because we don't count, obviously, the array that we have to return, because we're going to return that no matter what. But we're not using any auxiliary arrays when we're trying to solve this problem. So any extra space that we use is just like a variable here and a variable there. And those are not dependent on the size of the array, of the input array. Therefore, the space-time complexity is big O of 1, and the runtime is still big O of n. And it's a bit faster because, as you can see, it uses one less loop. Runtime complexity-wise, this does not matter, but there's a bit of a performance improvement because it's not the same looping, let's say, through 300,000 numbers twice than 3 times. It's always better to do less loops if possible, but in the grand aspect of things, it does not affect the runtime complexity. But yes, this is how you would solve this problem. It's a bit of a challenging one, so don't get discouraged if you didn't get it by yourself. It definitely is a creative way of solving this problem, but yeah, now that you've seen it, I hope that you can kind of like understand what this approach was like. And yeah, thank you again for watching the video. Make sure to hit a like, which helps the channel a lot, and see you on the next one. Bye-bye.